In this video, we look at the compression stroke of the combustion engine cycle, and we're going to identify problems. We're going to look in depth at error codes and issues that might affect this important phase of the combustion process and help you to diagnose problems and get to the bottom of a loss of power or flat spots. Now, what can go wrong on a compression stroke? Well, if the rings have become degraded, the compression is lost in the engine. It's not able to compress the air. Some of that pressure is being lost into the crankcase. It could be a blown head gasket or even scored cylinder walls. They can all lead to this loss of pressure on the intake stroke. When you're under boost, you need all the compression you can get. Running at relatively low RPMs, it doesn't matter too much, and the engine can compensate for any anomalies there, but it will manifest itself the minute we put our foot on the accelerator. A compression test is the easiest way to determine if this is the problem. You just unplug a spark plug, put the compression tester tool in, and just check the compression on each of the cylinders, and they should all be relatively close to each other. But if you have a runaway low compression cylinder, you can bet that that is at least a significant part of the problem. Low compression doesn't always produce a fault code, annoyingly, but you might get codes that relate to persistent misfires from weak compression. If it's not compressed enough air, it's not going to fire correctly, it's not going to burn correctly. So you might see a P0300, a P0301 or a P0308 error code. The P0300 part indicates it's a misfire, and the subsequent codes will give you a clue as to which cylinder is misbehaving. If the head gasket is warped and you're losing coolant, that can also lead to a pressure loss, and you might get some of those overheating codes, the P0217, or it may be causing a misfire on the affected cylinder because the coolant is managing to get in there. Variable valve timer. Your modern engine is able to control the opening and the closing of the valves. The cam does this job, but variable valve driving takes it to the next degree. Depending on whether we're operating under load, the engine is producing a lot of power, or you need the fuel economy, it can trim the opening and closing of the valves accordingly. If there's a malfunction in the variable valve timing system, that can cause this problem on acceleration. The valves are staying open or closed for too long a duration, and that means we're going to be down on power. And again, that's something that's going to manifest itself at higher RPMs, whereas the engine can cope admirably well at lower RPM. Oil condition has quite a major bearing on the VVT, or the variable valve timing systems. They're quite sensitive to wear and tear caused by the wrong grade of oil or insufficient oil pressure. Do check the oil, and a lot of these faults will manifest themselves straight after an oil change, particularly where the wrong grade of oil has been used. If that's the case, changing the oil for the correct spec will usually fix the problem, but if you run too long with it, you're going to have all these knock-on problems to sort out from that because you've ignored it. You might get a P0010, a P0020, a P0022, and these indicate a problem with an over-advanced cam timing on the intake or the exhaust side. The timing chain connects the crank at the bottom of the engine with the valve train at the top and ensures that the opening and closing of valves is all synchronized correctly. If that timing chain is stretched or the tensioner is not working correctly, that can lead to anomalies in the valve timing, and that can lead to similar problems that we've just discussed. You might get a P0016, a P0017, or a P0018 or 19, which indicates there is a crankshaft to camshaft position anomaly that the ECU has picked up on, and that will usually trigger a limp home mode. Check the chains, check the tensioners, check the belt, make sure they're not degraded and you've got sufficient tension in there. And also, if it's just been changed, make sure it's on correctly. If the tooth is misaligned slightly, that can cause these error codes and these problems. The camshaft position sensor tells the ECU where the camshaft is and helps it to make calculations and diagnose where the anomalies are actually occurring. When the sender fails or it gives an intermittent signal, the ECU is going to panic. It's going to throw the car into limp home mode to protect itself. You're going to notice this as a misfire, the engine idling erratically or misfiring under acceleration. This will usually start off as an intermittent fault and it will get progressively worse. The P0340, P0341, 42, 43, 45 and 46 all cover issues related to the position sensor. And don't forget that V engines have 2 sets of these camshafts, so the codes are tailor-made to give you a little bit more information as to which camshaft is causing the problem, or which camshaft position sensor is causing the problem. The crankshaft position sensor performs a similar function to the camshaft position sensor. It tells the ECU where the crankshaft is, helps it to make calculations as to where the pistons are in the engine, whether they're at top dead center or elsewhere, and significantly contributes to the smooth running of the combustion cycle in the engine. Intermittent signals from this crankshaft position sensor can cause the ECU to make bad calculations in terms of firing the spark, or other issues causing the ECU to run into limp home mode. Error codes to look out for are P0335, 336, 337 and 338. Fault with the circuit, fault with the range, signal low and signal high. If you're getting the P0335 and you're not starting, it's almost certainly going to be down to the crankshaft position sensor. If you've enjoyed the video, please boot the like button. If you're not subscribed to the channel, please do so. We'd hate you to miss out on the great content we've got planned. Thanks for watching. See you in the next videos.